Well, welcome everyone to IBMI in 2021. It's not just AS400, popular webinar we've done now for the last 5 years. We have a great guest today again with us, Mr. Steve Will, who will talk about AS400, Power 9, IBMI 7.4, cloud, and everything in between, and maybe even mention Power 10. And if you notice down on the right-hand column of this slide, we have the new IBMI logo that came out this year too, and you'll see some more changes coming in the future around that. So with that, welcome. This event is being recorded. We do have a few polling questions. You will get handouts afterwards, and certainly we'll do Q&A. This is a little bit longer event than normal. This is 90 minutes long, so hang in there as we roll across the top of the hour. We expect to continue to roll on. So Steve, what's your role at IBM? What do you do for IBM?
I'm the chief architect for IBMI, and that means I'm responsible for the strategy and the plan in development. I've been in this role now for 13, almost 14 years, 14 years this next month. So yeah, I've been doing this a long time, and one of the big things I get to do is to talk to clients about the strategy of the platform. But because I'm an architect, it's also great to actually talk the architecture, and that's what I get to do in this session.
So you are definitely a techie. You love talking technical things. Yep. You know, and then I'll be your moderator and host today, but we're going to hear mostly from Steve today. I'm the EVP of Technical Solutions here at Help Systems. Been with Help Systems and really with the AS400 iSeries IBMI platform for my entire career here of 30 some years at Help Systems, and also a power champion. Look forward to working with you all today. So Steve, 5th year in the row of doing this. We again are smashing the records when it comes to a number of attendees and stuff. Why do you think people keep coming back, or we get new people coming to this event?
Well, first of all, I think there are, of course, a lot of people passionate about the platform, and they know that their platform is different in many ways from other platforms, and they want to be able to understand it, maybe be able to tell other people about it. And because we do it annually, if someone heard about it, then they say, oh, I know that's coming up. I want to hear that again. Plus, I always do try to change things up a little from year to year. So while you're getting a bunch of the same core message, you're also getting a bit new based on what I'm doing. So hopefully some of that is driving it as well.
It will all come out in the end, right? So no, it's really a pleasure. And at Help Systems, we thank you for joining us again. What else better to do on a hot summer day than to listen to Steve Will in the morning and have some coffee, some tea, or wherever you're located in the world, because we realize this is a worldwide server. So let's move on, and let's do our first polling question here. Let's go on to the next slide, and I'm going to open up a polling question, and we want to know what your experience is on the platform. It's always good to see where you got started. More than 30 years, 21 to 30 years, 11 to 20 years, 1 to 10 years. Less than 1 year, and we consider people with 36, 38, System 34 as those that group that started more than 30 years ago on the platform. And Steve and I were talking earlier in the lobby about new things that have been happening around IBMI, and I'll shout out to there's some nice groups like iChimes, if you haven't heard about that one, the Incredible I podcast. Of course, we have standards like TechU. We also have a new newsletter. I've seen it quite a bit throughout the summer called Built on Power. That encompasses everything power, not just IBMI. Of course, IT Jungle continues to rock and roll, Common, DB2 Summit, and on and on and on with all the different user groups. Later on in the session here today, I'll have a URL that you can go out to if you're looking for a user group in your area, or if we're missing one, we'd love to update our list to make sure that we have that covered. Okay, well, I think that's enough time on this here first polling question. I'm going to close it out, and we will share the results. Steve, you should be able to see that now. Looks like, wow, we have 45% of the people have more than 30 years that are with us today. So you're the ones out there responsible for educating everybody else on IBMI. That's what I say to you. And then 21 to 30 years, the next big group, 11 to 20 years, 13%. 1 to 10, 9%, and then we have some people with less than 1 year. And honestly, I would hope on this particular session we'd have more and more of those people with less than 1 year. But that is what it is. We have a couple more polling questions for you, and I'm going to hide this polling question. And Steve, you should be able to roll through the deck, and the floor is yours, as they say.
Excellent. Well, thank you, Tom, and welcome everybody. And thanks so much for filling out that initial polling question. You know, I knew going into this, like every year, that as I present this architecture presentation, I'm talking to a lot of folks who have been on the platform for a long time. And so some of you will recognize this architecture as something that you've used for a long time. And you may well know it. Maybe some of you know pieces of it as well as I do, and that's great. That's wonderful. But I think I'm going to be able to teach you something, and particularly as we talk about the evolution. I find after I give this presentation, I'll run into somebody who will say, oh yeah, I forgot what a big deal it was to change to that. They forget that there are some things that since the introduction of the AS400 were new at one point and didn't start with the platform, or maybe we're never on AS400 at all, but they think of it as being part of AS400 because we've been able to continuously provide function and stability and so on. So anyway, we're going to do this evolution. If you've heard me present about the value of the platform or about the architecture before, you'll have seen this chart. This is the chart I typically pull out, particularly if I'm going to talk to a technical executive who is not used to IBMI, hasn't done IBMI before, to explain the pillars of what makes IBMI a different kind of operating system than any other operating system they've used. And we'll go through all of these in greater detail as we build this up. But having DB2 and our single level store architecture manage the data, having an object-based architecture, which is a key thing for protecting the integrity of the system, the integration of everything that you need, and these days for quite a long time now, pace to be able to put together a full suite of the necessary software for solutions, being able to run multiple workloads on the same system without having them conflict with one another. And that's long before anybody ever did things like hypervisors. And then the technology of independent machine interface. And again, we'll talk in more detail about each of these and how they've grown. But I'll show this chart, and that's usually what I get a chance to do. Now, sometimes when I am in a group of people, what I'll get is some clever person in the audience stopping me and saying, hey, you just called that the IBMI architecture. But really, isn't it just the AS400 architecture? Or if they've been around long enough, they say, or isn't it even the System 38 architecture? And so what we're going to talk about today is that evolution of this platform. If you start on the bottom left of this chart, sure, there was the System 36 and System 38. Some people can even say System 34 before that. Some people say System 3. You got to start somewhere. Certainly the System 36 and the System 38 had components which led into the architecture of the AS400. The AS400 architecture with those 5 pillars that I just showed you was the starting point for those 5 pillars. We can argue about System 38, but let's not argue. Over the years then, we have taken those 5 pillars and we have evolved through a number of different technology changes, and of course, through a number of name changes as well. Now, I'm going to be talking about the simplified version of this. We're going to talk a bit about what the System 38 and System 36 contributed to this base architecture. And then we're going to go along through time talking about various things that happened that were milestones in the architecture's development over time. In many ways, there was a big change in about the 2000 timeframe when we became I-Series. And in a lot of ways, there were changes when we became Power Systems. In fact, Power Systems in 2006 was pretty important. And then when we became 2008, One Converged System absolutely was important. And then we'll talk a bit about the things that we have done recently that continue to evolve this architecture. Now, what we do with this architecture always has to support the strategy of the business. And again, if you've heard me talk, you've heard me talk about the strategy of the platform. And I'll just briefly say, we're a solutions platform, so the operating system supports the solutions on the platform, but we're also making sure that you get the value out of the power architecture. We give you choices using open technology, so you know how to get from one place to another with whatever option makes sense to you. And then we'll integrate all the new technology to make it easy for you to continue with a very securable, reliable platform. That's the strategy. Now, that strategy was initially created in this format by me when I became chief architect, shortly after I became chief architect in 2007. And while many people would look at that and say, yeah, that's the strategy that's been around for a long time, I do want to point out, and one of the reasons to do the presentation this year again, and in this way, is that if you compare what the IBM strategy is to what AS400's capabilities are, you will see that in fact the AS400, as it was initially architected, couldn't fulfill this strategy. Sure, AS400 was a solutions platform, but it wasn't a platform on a mainstream platform that IBM wanted to continue to invest in. Okay, when the power technology came into existence, it was a technology that IBM wanted to invest in and use in many, many ways, and not do the proprietary AS400 way of doing things. And so we needed to change the architecture to allow us as a platform to share technology across IBM and across the industry. Storage, for example, we needed to be able to incorporate storage that you could purchase anywhere. The kinds of things that clients want to do with their applications these days required a level of analytics and mobile and incorporating Internet of Things that the original AS400 architecture simply could not handle. And so there is a difference in terms of the architecture necessary to take this strategic element and implement it that the original AS400 could not. I will go through time talking about the evolution of that architecture, and you can see how some of these requirements that are coming in this strategy are going to affect the evolution of AS400 at the end of its naming lifespan, right, as it got to 2000. But then it really took off in the series and then IBM timeframe. Being an open platform for choice, AS400 simply wasn't. It was proprietary, and until it got pace, it really couldn't do much that was open at all. And so being able to do open source languages and applications, there was almost no real way to do that. I mean, the most open thing we had in the AS400 timeframe before pace was Java, and that at the time, if you'll recall, wasn't open so much as it was pervasive. So this part of the architecture in particular needed to evolve so that we could provide clients choices on how they move forward and incorporate open technology and get people onto the platform who knew newer technology that wasn't specifically tied to AS400. And so again, I put this, we put this together, this strategy years ago. We didn't specifically call out the fact that the AS400 as it was designed wasn't built to do this, but it could be evolved to this, and that's what we've been working on. We've been working on the evolution to make sure that we could carry forward all the value from the AS400 architecture and be able to do these things. So where will you find the AS400? Well, it's in that integrated part, right? The continuity between IBM and AS400 is a bunch of this architecture that was an integrated architecture that allowed us to have a low total cost of ownership. It provided the personality of the machine. So a high value platform that was simple, that provided exceptional security and resiliency. All of that certainly was an AS400 value proposition that was supported by its architecture, okay, and we needed to carry that forward as we evolved to be able to do the things above it, and you'll understand that better. But I do really want to point out that one of the key things we always wanted to be able to do was leverage other parts of IBM, including storage and software technologies, and we always had a struggle with incorporating that stuff within the AS400 architecture. So as we go through this, recognize that I truly appreciate the AS400 architecture. It provided us the base, especially for that third pillar, okay? But we needed to evolve it, and we're going to talk about how that happened throughout the rest of the session.
Great start, Steve. I'm going to roll us into our next polling question, and this will be kind of a fun one in my mind is, what do you call this platform most often? Select one. I know you might call it many different things, but we're going to catch you here. What's your most common name for it? IBM I series, AS System IBM Power Server. And Steve, as we were talking yesterday, getting ready for this session, I often run into customers and they have and I get to see their system names and stuff, and they'll have systems called AS400A and AS400B, but they're running IBM I 7.3, 7.4 on a Power 9 server, and it's in a way it's somewhat comical, but in another way we're our own worst enemies on this topic. What do you think about that and the naming?
Well, right. So, I mean, IBMI is what it's been called for essentially the entire time I've been chief architect. So it flows off my tongue easily. But I recognize that part of the value of this platform is that we didn't force people to big change as we moved along in many cases. And so what people called theirs a long time ago, if they're continuing to use them, it's understandable why the system name would be what it is. I just hope that people, especially after hearing this presentation, understand that IBMI is so much more than AS400 ever was. And so when we talk to clients or when we talk to our compatriots out in the technical world, we want to make clear that we're using a modern operating system that can do all of these things. And that's what IBMI means to me, right? Based on that prior technology, but means more.
Yeah, so let's take a look at our results. We'll see, okay, 45% are saying IBM I, 19% still I series. I do run into quite a bit of that myself. And then AS400, 31%, and System I, and IBM Power Server for those who probably run AIX, IBM I, and Linux, right?
Yep. Because the machine is part of it, but it's not all of it. Yep.
Exactly. It's pretty interesting results. Well, we thank you for that. And one of the things I can't think of the executive IBM. They used to always call the IBM I system the proven system versus legacy. I've always liked that. It is. I mean, it's during this period of COVID, if you think about one of the value propositions of IBM I is it ran your business and it continued to run it. You didn't have to the issue of worried about it's going to be down and you have to send somebody into the data center to or whatever reboot it. So at least I hope that was your experience. It should have been.
All right. So let's get on. As I said, these are the core elements, and you're going to see them show up at the bottom right of many of my charts. And what I do in the bottom corner is I try and sort of point out to you which parts of the architecture am I talking about. So first of all, let's all understand, you all know, right? We are not your general kernel operating system. A kernel operating system tries to be as thin as it possibly can. This is what all of the ICs, Unix, Linux try to do, okay? And when an architecture picture is drawn of one of those kernel-based operating systems, the operating system is as thin as it possibly can be so that it can virtualize for those user programs and application programs. From the beginning, the architecture that OS400, the original AS400 had, could be recognizable. You have these applications that sit above a part of the operating system, but then the operating system itself was considerably more complicated than that. There were several different layers to that thing that in other operating systems would be the kernel. And rather than try to make it thin and simple, what we tried to make it do was to be versatile, long-lasting, okay, and virtualizing the capabilities underneath it for very good reasons. I highlight, for example, the machine interface part of the architecture there because there's so much of this operating system that sits below that machine interface so that we can do things. Another key part of the platform is the storage model, which really does go back to the System 38. System 38 created this idea that all of storage should be viewed as one big memory space. In fact, you can have a memory space that's much larger than the physical storage that you have, and that the operating system itself should figure out where to put any given thing. So rather than having to manage individual disk devices, storage devices yourself, the operating system would take care of that so that it could decide where should I put any given piece of data. And could then over time change where that data was if we could improve your, particularly your performance. And so the storage model together with DB2 made it possible for us to manage your data much more intelligently, even from the very beginning, before anybody thought of the idea of doing autonomics. That ability to spread data and manage that data without having the user have to get involved is critical to the architecture, and is critical to having an integrated database like we did. Now, part of that storage model was to realize that storage was going to be used to store data, but it was also going to be used to store software. And software is going to have special things that it needs to do. Now, I hope most of you have some programming experience so that you understand what I mean when I say pointers, right? Pointers within a program are an address of something. Pointers are not just data, they're an address of something. And we, from the very beginning, this architecture looked at treating them in a special way. They added this thing called tags that said if a particular piece of this memory, the single level store, was going to have a pointer in it, we were going to tag it that way so it could be treated separately. And that is critical for a lot of different things, but it's particularly critical for how we protect the integrity of the system. And you'll see that over time, especially as I talk about how that advanced. And so System 38 single level storage was there for us to use as we moved into this combination of System 38 and System 36 that became the AS400. But was it the same thing? It was, in fact, not the same thing. AS400 changed single level store from System 38 when it was introduced. So those of you who thought that the same architecture has been around since System 38, well, there are portions of it that have, but even from System 38, single changed. You see, AS400 architects decided that there would be some benefit sometimes of being able to group particular physical storage devices, and so they created this thing called an auxiliary storage pool that could allow you to treat this one addressable set of memory as individual pools of memory that would have slightly different characteristics. So even that core element that some people think came from System 38 unchanged, how we treat each of the pools is very similar to how we treated System 38 single level store, but IBM AS400 single level store changed in that it's not so single anymore. Technically, it's all still one user space or address space, but how it was treated was built on these auxiliary storage pools. Another key element of that storage stuff was, what are you doing with that storage as an application? You're storing data, and so you have to have an integrated database. Now, because the AS400 was created from the System 38 and System 36, we actually had two database models, two database architectures that we had to incorporate and adapt to. And so we had to be able to, in the original AS400 database, be able to deal with System 38 database interfaces, but from the very beginning, the strategic interface was going to be this SQL interface, because we recognized the power of having an SQL fully relational managed set of data, but we still had these side things that we had to be able to continue forward. And as Tom mentioned, sometimes we're our own worst enemy. The fact that we let those things come along with us and continue to be supported allowed people to move with a lot less disruption throughout the years, but it also kept some people using that older technology when they could have gained benefit from this SQL interface. Our object orientation is really complicated to explain in detail, but at a conceptual level, it's not all that difficult. Rather than having one thing, I hesitate to call it an object, one file, say, on another operating system where everything was contained in it and anybody who had access to the file could find a way to get into it. We had these things called objects that were separate. So there are parts of any given object, whether it's a program or a file, that you as a user cannot get to. You cannot see the metadata associated with it. And there are only certain ways you can operate on an object given the object type that it is. And that was a concept that was in object-oriented or object-based theory of software at that point, but no one had built an operating system on it. And so we certainly have taken advantage of that throughout the years as well. So you can't do things like rename a file to look like an executable, or rename an executable to look like a file, and then do different things with it. Then you should be able to do it. That's not part. So that base architecture, I've been sort of all through most of the architectural elements here, was part of that AS400 V1R1, very beginning, 1988 architecture. It was perfect, right? It didn't need to change at all. See, that's the attitude that I often get from snarky people, is that, well, this was just the architecture that we had when we initially the operating system. And no, in fact, something happened. And that's what you'll find, even in this trimmed down and extended both version of this architecture presentation, you'll find that there were things that happened in the IT industry that caused us to have to make a change to evolve the operating system. So remember the single level store thing? Well, when all we had was the initial RPG and COBOL, that was fine, because the initial RPG and COBOL were very limited in terms of what they could do. But we almost immediately wanted to begin using the C language. It was very popular within the industry. We could see that it could do things that other languages, RPG and COBOL, couldn't do. And so people wanted to be able to use it. So we wanted to be able to support it. But what does C programming have in it? It has pointers. Why does that matter? Well, if you, in your application, have a pointer, it is a pointer into this thing that we've said is all of memory, therefore all of storage. So if you have a pointer, what is to keep you from adding a bunch or subtracting a bunch from that number and then moving your pointer to be addressing something somewhere else, like, for example, in the operating system code? In V1R1, with the architecture that existed at that point, there was no way to prevent you from doing that. And now we had a language in C where that's what people were going to be doing all the time, was taking pointers and adding and subtracting to them. How are we going to keep them where they ought to be? Well, we had to create security level 50 and create the initial hardware support for hardware storage protection, where we could say, no, you're trying to do something to this tagged piece of memory that says it's a pointer, and that's going to put you outside of the bounds of where you ought to be. So we're going to cause an exception, so you can't do that. Now, the architecture had been set up so that it could do that, but it was not implemented in the architecture. The architecture wasn't fully formed, and so that had to be done. So already right away in V1R2, we had to do something because the architecture needed to be advanced, needed to be evolved in order to accommodate the kinds of things that was going on in software. Another part, a key part of what goes into a piece of software is the file system, how you use the data, how you store the data. And System 38 had one file system, and that got carried forward to AS400, qsys.lib. Very, very familiar to those of you who've been around for 20 or more years. Very, very unfamiliar to anybody who's joined in the last 10 years, where you've never seen something like a file.member architecture. What in the world is that? Well, System 36 had implemented already this thing that was a system-wide file system that was more the kind of hierarchical file system than that other people in the industry were beginning to use. The industry defined a standard hierarchical file system as part of what they called the POSIX standards, okay? And this is the file system that every other operating system that succeeded wanted to be able to do. Start at the top of the tree, go down, go down, go down, split apart into branches, etc. It's a hierarchical thing. And so AS400 had to adopt that approach, and we built this thing called the integrated file system, which was a common set of interfaces over many different file systems, though many people just tend to think of it as VIFS, where we have the standard sort of Unix-like or Windows-like, but Unix-like really tree. So today's modern applications assume a standard hierarchical file system. When they are written, they assume we're going to have a POSIX type file system, and that's what the IFS provides. So again, AS400 had a great beginning, but it did not have what it needed to have in order to grow into the kind of software that was going to be produced throughout the industry. So we had to add that to the architecture. So we had that inciting incident. People not only were writing in C with pointers, but they were beginning to assume that there was going to be a storage that was going to be a hierarchical branched file system underneath it. And QSys.lib just could not do that. There was no natural way for us to interpret somebody's file or somebody's hierarchical file system into a file member kind of environment. Another thing that became an inciting incident that allowed us or forced us to do something different was the move away from monolithic programs. Again, those of you who are relatively new to the platform, you need to understand that back in the day, 30, 40 years ago, in order to better, more efficiently use the storage that you had on your system, and particularly the memory that you had on your system, you would write pieces of software that had all of the logic in one executable in a monolithic program. There were very good reasons that things sort of evolved that way or started that way as platforms. But as resources became more and more available, it became clearer that if you could write software in a more modular way, you could make it more maintainable, you could make it more reusable, you could make it more understandable as a piece part, etc. And so people began to want to do more modular programming. And so we needed to invent something within the IBM AS400 architecture, which would allow modularity to be not only possible, but beneficial, be better than doing something in a monolithic way. And so this is one of those pieces that people forget. It didn't used to exist within the operating system, but it was a big deal. We had to create the integrated language environment, ILE, also used to be called the new program model, which would allow you to create modules, bind things together so that all of the necessary resources to be able to call from one of them to another and have the necessary environment around it, all of those things could be done. Rather than having a single monolithic program object that had to take a whole lot of time to call another single monolithic program object, you needed those things to be modular enough to be able to carry only what was needed, but everything that was needed as they built themselves up into composite blocks made up of these modules. And so an ILE had to come into existence, not just as the program, but to create a group, an activation group that would get activated at once and have a set of shared resources that were inside a job and so on. So that was a key enhancement that was necessary throughout, and it allowed you to have, with this new architectural element, something that would control the birth, life, and death of processes and the activation groups so that you could do modularity and you would gain benefit from it. What you'll find over time, if you're as involved in the evolution of this architecture as we were, is that these new ideas could often be implemented using the older technology, but they wouldn't be beneficial until we actually changed or invented a new part of the architecture. And then things got better. So we could create, for example, a module, but until we actually had activation engine and the activation groups, we couldn't actually make it work really well. And so that's when the ILE came into existence. Similar thing happened with the structure that controls the running of a program. Okay, so in our operating system, for those of you who are newer to the platform, we have these things called jobs, and jobs are implemented internally in the operating system as these things called processes. Okay, and jobs and processes were everything that you needed to run a piece of work. You could start your job, run your program. That was great, but they take a lot of time to set up. Now, a lot of time relative to what? When they first came into existence, they were the only thing, so it wasn't a lot of time relative to anything. But within the industry, applications wanted to be able to kick off work asynchronously and frequently. And when they wanted to do that, there were these things called threads that were created in the industry. A thread, similar to a job or a process, was the thing that allowed a piece of software to be run inside of it, but there was much less metadata associated with it, so it took much less time to create it and for it to disappear was not that big a deal. There wasn't a lot of cleanup to be done. So in the industry, threading became the way to write something. If you're going to write a piece of software and you wanted to kick off a different piece to do different things, you kick off another thread, it would go off and do its thing, leave something behind, or report back what it needed to do, and then it would cease to exist. That threading needed to be created within AS400. How are you going to do that? Well, initially we created so that you could just have a few threads. There would be one thread per process per job. Well, that doesn't sound like threading. That means every time you got to kick off a new thread, you got to kick off a new job. And we already said that takes a lot of time and a lot of setup. What that ended up being when you tried to put a multiple thread, a significantly number of an application that was using a significant number of threads on the machine was a mess. It was just a mess that did not perform very well. And we would have never really cared all that much, or we might have never really cared that much until we found an application that we really wanted to run really well on our platform, which was Lotus Notes. IBM had purchased Lotus. Everybody in IBM land recognized that people were going to be using email. This is the email that we owned. Of course, Lotus could do a lot more than that, but at the beginning, what people really wanted was email, and we didn't want people relying on our competitors for email, so we wanted AS400 to have a really excellently working email application, and that was Lotus Notes. But Lotus Notes required a huge set of nicely managed threads to be able to do that, and so we said we can't have this single thread model anymore, where a single thread is within a process within a job. We had to have something more than that. And so we had to create an environment where you could have multiple threads running really, really well within one another. So Lotus Notes helped to drive our evolution to creating threading. Now, we have not reached the end of AS400 timeframe yet, but you can see already that in order to be the kind of solutions platform that we wanted it to be, we need to be able to adapt to the kinds of things that were going on in the software industry that had not been in existence when this architecture was initially created. Another part of what we had to adapt to was the hardware changes underneath. Now, this again had been anticipated by the architecture when we created this technology independent machine interface. What we wanted to do was to isolate hardware changes from the software applications that were sitting above it, that stuff that we had virtualized to. Okay, so in IBM, we had begun to recognize that we were going to move away from this proprietary platform, the CISC-based, AS400-based platform, to a RISC-based platform that was going to ultimately be able to serve more than one purpose, be there for more than one operating system. That's not the way it went at the very beginning, but we needed to move in that direction. And so we had this wonderful thing called the technology independent machine interface, and we had said from the beginning that we'd be able to change everything that was underneath it without people noticing who were running on top of that machine interface. So while we started out with this vertical machine code, horizontal machine code architecture, the original kernel, much bigger than a normal kernel, running on top of this 48-bit CISC processor, we needed to be able to preserve all of the programs that were written to that technology independent machine interface, but run on this new 64-bit RISC processor. And that, by the way, required an entire rewrite. We did not get to save more than a fraction of a percentage point of the code. We had to write entirely new stuff below that MI. That's why that transition was so critical. It's also why it was so difficult for us, and why there were a few hiccups with a few pieces of software as you move forward. But in general, we proved the value of this machine interface by being able to change from that 48-bit CISC processor to a 64-bit RISC processor. And every hardware change that we've done since then has taken advantage of it. So did the architecture change? Well, above the MI, it didn't look like a different change. You were still using the architecture, but below the MI, the architecture changed significantly. How we did I/O, how we were managing processes and tasks that support those processes, and how we were getting in memory, everything changed underneath that. And we have had multiple changes since then, which have been able to be insulated from the users above it as we grew, for example, to being able to do not just single cores, but fractions of cores and multiple cores, not just one thread per core, but multiple threads per core, and so on. All right, so we have now sort of reached this transition point. I'm going to let Tom talk for a couple minutes while I take a drink, and he tells you a few things, and then we'll get back to it.
Sounds great, Steve. If you can flip us on to the next slide here. Just wanted to take a break, give Steve a little break here. I'll remind you, Help Systems, what we do for IBMI. We're a business partner, have been for a long, long time. And we provide solutions for helping people with backup and high availability, document management on IBMI, cybersecurity IBMI, monitoring the system, business intelligence. We help you do your planning, your capacity planning. And of course, we do automation technology, all centered around IBMI. We have a great staff here at Help Systems to help you out if you have any needs in that area. And we can move on to the next slide then. Hopefully Steve is still listening. The other thing I want to remind you is that, we have several of us that are members of the IBM Champion Program, a great program that IBM has put together for many years now. I myself have been involved in it for 6 years. I think Robin for 4. Amneris is new. And then I have a colleague, Chuck Lazinski, who works with me a lot on the IBMI side. And he's our local vice president of our user group called Q User. And I actively encourage you to get involved in Q User too. So let's move on to the next one. And when we think about Help Systems, we also do a lot of other thought leadership for the IBMI community. I started the annual IBMI Marketplace Survey. We put that out now for 7 years to give you yourself a PDF, a webinar, and other artifacts that you can share with your management and help explain why people are on IBMI today and where's it going. We also have been putting out for 19 years the annual State of the IBMI Security Study. I also spend a lot of time just talking one-on-one with you as a customer. If you're looking for a discussion, you want to talk about, really anything IBMI, there's no topic that's really off too far. We'll do pretty much talk people through HA challenges and security challenges, et cetera, on the platform, development, modernization, whatever. We also have we're members of the Solution Edition program at Help Systems, and certainly you can get discounts and stuff on our software through that program. And then finally, I want to remind you, we have a nice landing page for user groups around the globe, and it's on our website, something that you can go out and launch and help join other user groups. Okay, let's move on to next slide here. And just to remind you again, the Marketplace Survey, the reason I have this in here is that we will be opening up this again for the 8th year in the row. And look for that to be open probably in the September timeframe. I'll know a little bit more. I have a planning meeting this afternoon on this topic itself, but we look to continue to do that. And let's go on to one more slide here, I believe. Or actually, got 2 more slides here. Quickly, security study, that's also a downloadable piece. We've done that for 19 years. If we go to the next slide, Steve and team at IBM have done a great job of security into this platform. The whole object-oriented discussion and security being built in with each and every object. We take a look at that system with our free security scan, and we point out the high-level things that you as an organization probably should take a look at. And as we go to the next slide, I'm here to say our results that we get from the survey are not always as good as we'd like to see for you and for your systems. We have too many people running, I say, root profiles, all object authority, just because I talk to a lot of people that don't understand IBMI, so I talk in their terms, root. But then security level, minimum security levels aren't being met. People aren't monitoring exit points. And as Steve talks today, this is a modern operating system. People aren't just coming through Telnet these days or 5250 sessions. There's a lot of other things going on, and even the risk of potentially hosting or storing a virus or malware out on the operating system, not in the operating system, but in the IFS. Move on to the next slide here. And I think we're on to our last polling question. And just kind of quickly, what does Help Systems get if you're interested in any of these things that I've talked about? You can fill out and request information on capacity planning and monitoring. If you have some data access needs, you want to talk to people about business intelligence, data warehouse. We're kind of unique. We actually have data warehouse technology that runs on IBMI. There's a lot of failed data warehouses out there, Steve, And that's because people have been trying to extract IBM data for years and put it over on Microsoft, which can't handle terabytes and terabytes of data like we can in an IBM partition. Also, HADR concerns, we see a lot of people still struggling in that area. Document management around IBM, we've been very successful in helping people, especially during this COVID period, take some of those manual things that you've been doing with handling documents and automating, accounts payable processes, invoicing, et cetera, et cetera. And then, of course, the free security scan is always popular. It doesn't cost you anything. We have some customers that take that scan each and every year just to kind of get a level set. We have to have continuous improvement when it comes to cybersecurity because the hackers around the world aren't taking a day off. All right, so thank you for filling out that last polling question. And enough of me. We want to get back to the main guy here, Steve Will. And Steve, back over to you to share and talk about, I guess we're at I-Series now, right, in the evolution?
We're getting right in that transition period from AS400 to I-Series. There are several things that I'm going to be talking that. Can you hear me now,
It's
Tom?
about year 2000. Yep, I can hear it's about year 2000, right?
Yeah, right about 2000. Yeah, right about 2000. All right, so there are a few things that I'm going to talk about here that were happening as the millennium changed. First of all, we all recognize, who are old enough, that there was a major tectonic shift in the industry when people started using web browsers. This just happens to be an image capture, the very first web page that was ever created. But in terms of business, people began recognizing that there was going to be great value in being able to drive information and ultimately transactions out through the web. But that meant that a system that was going to be a business system had to have a web server. But as so frequently happens in our industry, the original web server architecture that was created, while it was one of the first things that was adopted by many systems, including AS400, it was not the kind of architecture that could be sustained and grown throughout the rest of the lifespan of computing. And so we actually had to implement several different web servers over the course of the end of the lifespan of AS400. And when we finally got the Apache-based web server that serves as sort of the basis web server that we have today, it was right at the end of the AS400. We were just about to change names into the I-Series and start trying to do the conversions that would ultimately happen. So it needed to have the threading that I had talked about shortly before we took our little break, okay, but it also began to drive requirements for things that had never been in the operating system. And so it was during the invention of the I-Series version of the architecture that we began to incorporate digital certificates into our security model. We created a server architecture within the system to be able to create different kinds of software servers, including a web server, but it wasn't the only server we could anticipate coming. And sure enough, there were print servers and web application servers and so on and so on and so forth. So we had to create an architecture for that. And then we had to have this thing called TerraSpace, which I'll talk about later. It's a way of managing memory/storage while you're doing something that's going to be web-like, which was very different from doing things that were traditional transactional programs. So there was a significant set of changes that were required to the architecture to adapt to. Now, one of the things I haven't talked a whole lot about, and I do want to talk about here, is the database. DB2 as a brand existed from the beginning of the AS400. And I showed you that we had to deal with the fact that we were using and supporting database architectures from the System 36 and the System 38. And so when you talk to a database, essentially what you're trying to do is you're trying to get answers to a business question. There's data that you have and you want to find out something from that data or about that data. And so you would create a question that you would pass into the system and DB2 would give you an answer. Well, in the older technology that we needed to support, it could only handle relatively simple questions. It could only go so fast. As I said, from the very beginning, DB2 architects wanted the strategic answer to be an SQL answer. We could all see that SQL was going to provide a very powerful, adaptable way of doing questions to data, and that it would have advantages that those older technologies couldn't have, like being able, for example, to learn from what had happened in the past. You're probably aware of this, but just to make you fully aware of this, when you do a query against DB2 for I, it keeps track of what it did underneath the covers and then figures out how could it have done it better so it would be faster for you the next time you do it. And so if you do query after query after query that are very, very similar or the same, DB2 for I will speed up because it will learn things. With the original architecture, the original kind of querying without SQL, we did not have the infrastructure, the metadata necessary for us to be able to learn that stuff, but it was possible for SQL. And in fact, using the infrastructure and architecture of SQL, one query could inform and improve a subsequent query that didn't really look a whole lot like it, okay? But we knew that that was there. So if we were going to take advantage and say, you know what, let's build an engine that assumes not that we're going to be getting this old style question, this old style query. We're going to build an engine that assumes we're going to be getting SQL, because while it's considerably more complicated, the performance and the ability of this thing to perform complicated things and learn over time is going to be significantly better. So we created this new query engine, but we had to continue to support the existing query engine. So over time, what we did was hand more and more of the different kinds of queries that are being done within the operating system to this new query engine, giving you automatically better and better performance, more and more learning over time, no matter how you were going at the data. But in particular, trying to do it for those SQL queries. And so while still some queries go to that older query engine, almost everything else, particularly the SQL, goes through that new query engine. So we, over time, tried to make sure that you weren't disrupted by this, but that architecture had to change. And again, this is in that time frame where AS400 stopped being sold, the I series started being sold, and we were starting to converge a lot of our technology. Still, DB2 for I doesn't share code hardly at all with any of the other DB2s, but from a design point of view, in terms of understanding what's available and so on, we were able to work more with DB2 across the other platforms. DB2 also needed to start dealing with this new kind of data query that is more than just a query. Analytics. People began to say, if you could organize your data instead of in rows, but in columns, where you had all the data associated, for example, with prices or transactions or something stored in one way, if you organized that data differently on other databases, you could answer questions that are the different kinds of questions than what you did before. Well, within DB2, we are already architected to store things in row-based ways and have those supported by single level store, okay? But we invented a way to make it also appear as if that stuff were stored columnar, in a columnar fashion. So you could do analytics directly on your data using essentially something that appeared to be stored based on columns instead of based on rows, and get the benefits of doing analytics in a high performance way without actually having it stored that way on disk. But what do you care? What do you care that how it's physically stored on disk, as long as you can get that analytics built right in? And as Tom was saying during his little break, you don't have to move stuff off of IBM I, transform it into a different format in order to get this information. You can get it from there. So that was happening and being added in that IBM I and then soon to be System I time frame. Remember those auxiliary storage pools that I talked about before, where you could manage storage across the single level store in different groups? Well, we needed to create something called an independent auxiliary storage pool, something that could be separated out of single level on one machine and then either added back in at a later time or ultimately even transferred and inserted into the single level store on another machine's memory. That was a significant, ultimately very difficult change within the architecture, but it also was absolutely critical to something that would come very shortly. I'll talk about it soon. Okay. And then I mentioned briefly, but didn't describe for you, this thing called TerraSpace that web browsing and web serving really needed. You see, before web programming came into existence, most of the business software that was written around transactions that was presumed to need to leave a lot of data around. Web serving is very different. Web serving, the software comes into existence, gives you some information or performs a transaction, and then goes away. That's just the nature of things, okay? Well, if you're going to do that, the storage that you use within your software probably doesn't need to stick around. It doesn't actually need to be written to single level store that's going to go out and be stored on disks. What you really need is storage that's very, very quick to quickly create, use, and then disperse back into the storage pool and not have that cost a lot of time, money, and resources. So we had to invent this thing outside of single level store, which would be which will allow any given program to have a huge amount of temporary storage that they could use for as long as they wanted to run and then go away. And in fact, we had to invent a different kind of pointer structure to be able to use for that sort of temporary storage that's there. Many of you probably aren't even aware that your software is using it. We'll sometimes ask people questions about whether they're using TerraSpace. And if you're a software programmer who had to come from the old program model to ILE and then to use TerraSpace, you might be well aware you're using TerraSpace because you had to do stuff to get that temporary storage. Okay, but if you're just an ordinary programmer writing the kind of software that runs based on web app serving these days, you don't know it, but you're using TerraSpace all the time. And it didn't used to exist. It came into existence at this point in the architecture. So now we're to that point, as I mentioned, where we're getting into this I series and then IBM I world. And this is where I really start talking about the things that have come along since I series. So we're not only passing AS400, the 12-year name that we had, we're getting rid of or moving past the I series time frame, which we were for 2000 to 2006. Once we became IBM I on Power Systems at 6.1, there were several architectural changes that happened that never existed before. We had to do a retranslation at 6.1 in order to do a couple of different things. Improving security, integrity, and performance was primary to this retranslation. Now, again, this proved the value of the technology independent machine interface. We were able to do this, and unless you had removed observability to your code, which basically took away all of the underpinnings of how we translate from your compiled program down into the language of the processor. Unless you had totally ripped that away, you never noticed that we did this retranslation. It took a little time when you started your program for the first time. If, unfortunately, you removed that observability, there were things that you had to do. Why did we do this? Why did we retranslate everything that had been written in the MI at that point? Well, there were a couple of key reasons. One was about the integrity of the platform. Just like your pointers could, in the early days of the AS400, be pushed off to point to something in somebody else's space or into the operating system space. There's a part of memory that's used as the program is running, which is called the stack. And the stack has information that the running program uses, some of it for the program itself and some of it for the operating system. And before 6.1, we had a single stack. Okay, there was as the program was running within memory, there was a single stack. So if you had a pointer to your stack. If you could find a way to get a pointer to that stack, you could, using addition or subtraction, get that pointer to point somewhere else within that stack that might be outside of what the user program should be doing. Okay, this introduced the possibility for malicious or unintentional, but mostly malicious, ways for people to mess with what was going on within the operating system. And we wanted to get rid of that possibility. And so in 6.1, we retranslated to have each of those pieces of the stack, the user program and then the two parts of the operating system, have its own separate, unaddressable from one pointer to another parts of the stack. So as we retranslated, now all of the executable instructions were such that it was assuming a 3-stack structure. A user program could no longer take a pointer to its stack and find a way to get somewhere else. This improved the integrity of the platform. We also used this to improve TerraSpace. When TerraSpace came into existence during the I-series part of our architecture evolution, it was initially implemented only in software. So as we created this ability to have temporary storage handed to each job, process, and thread that it could use and then just throw away, we had to do that all within the operating system. But we knew over time it was going to become so popular to use this that we wanted to make sure it could go fast and be protected. So we wanted it to be implemented within the hardware, within the instruction set of the platform we were running on. And it wasn't until the converged power chips that all of that was in. Okay, so now we needed to be able to retranslate so that instead of implementing TerraSpace in the software in the operating system, it was also implemented in conjunction with what the power processor could do. And so that happened at 6.1 timeframe. Again, the use of temporary storage to be able to do things like web programming, web app programming, and all the different kinds of programming, mobile programming, Internet of Things programming, all that stuff that is part and parcel of doing that relies on TerraSpace, which could not perform using a software-only way of doing things. And so we had to implement that.
Steve, this is Tom, just to give you kind of a level set where we're at too. We're right at the top of the hour, just timing wise, okay?
Thank you very much. Yep. I've got about a half an hour left and I will try to leave 5 minutes for questions before we're done. I think I can do that. I don't know if anybody's input any questions, but if you haven't, I'll try to get to something by the time we're done.
We have a few questions out there right now.
Excellent, good. All right. Now I mentioned before that independent ASPs, the ability to take a part of storage and pull it offline and put it back online, either in the initial place or on some other single level store implementation, needed to come into existence. And part of that was because we knew we wanted to be able to implement something like PowerHA, which was replication built on this idea that you could have storage that was owned by one system and then, because of a failover or a role swap, use that exact same storage running in another system. But of course, since single level store was initially defined to be one system's memory space, independent ASPs needed to be created before you could take that memory space and add it to some other system. And so PowerHA began to use that in this time frame as well. And boy, it's critical that we did, because there are so many clients in our marketplace who wanted a technology that was going to be built into the operating system that would help them do that. Now I know there are other high availability solutions. Help does them. There's nothing specifically wrong with them, right? But they're based on a different kind of technology. And some clients like China Merchants Bank and many others wanted to be able to take advantage of the value that could come from that independent ASP thing. So it's not the only way to do things, but the architecture evolved because there were some client bases that were going to need that. Now, perhaps the most critical thing in the creation of the IBM I architecture that exists today is this thing called PACE. By the time we got to the year 2000, AIX and what was then OS400 and became i5OS when we became I-series. Okay. What AIX and OS400 were able to do was to run on the same power processors. This was leading us towards the convergence that would ultimately end up in power systems, one system that could run 3 different kinds of operating systems on it at once. But at that time in 2000, we were not yet converged, but we were at least able to run AIX and OS400 on the same power processors. That created this possibility that if we had an executable that was compiled to run in AIX, it could run on the same processor. And if we could just find a way to marry that with the stuff that was based on the AS400-like or MI-based architecture, we could have 2 executables running in conjunction, cooperatively getting a piece of work done. PACE is the environment that we created within I-series to be able to take advantage of that capability. Then a piece of software running in the MI environment could call out to something that was running in this AIX environment, and then could get results returned to it and could continue on and process. Okay, PACE is what was invented. I'll show you a picture of kind of the architecture of it in a couple different ways in a minute. But in order for PACE to do that, it had to be able to get memory from somewhere. And how did it do that? With TerraSpace. Because basically PACE was going to treat every executable that's going to run in it, every AIX binary that's going to run in it, as a temporary program running for a short amount of time. And so rather than give it some piece of single level store that was going to then be written out to storage every time you did something with it, we just gave it a piece of TerraSpace, allowed it to use that storage for as long as it needed to run, and then voila, as soon as they were done, it was gone and there was no visibility of it. So PACE can only see memory that PACE acquired from the hosting MI-based environment it was running in, thus eliminating a lot of the worry that came along with Unix-based exposures on Unix platforms. Okay, there are things about how Unix and Linux does things that because they're running within a Unix, you don't have to worry about when they're being essentially fenced in by ILE by giving it only the TerraSpace that it needs. All right, so what does it kind of look like? It looks like on the right-hand side here are the ILE type programs that are using IBM I, but then applications on the left that are written in PHP, Ruby, Node, Python, they use these shared libraries. They're executable, the applications are executables compiled for AIX, and then we have these shared libraries that allow us to execute those executables, and when they need resources of some sort, or when they need to communicate back to software that in the ILE environment, there is these special system calls that allow us to do those things. And all of that then sits on top of this virtualized power hardware that we all run on top of, whether we're AIX or Linux or IBM I. PACE then allowed IBM I to host Java, because that's how Java is implemented, which was critical because all of our SAP clients, and we have thousands of SAP clients, needed to be able to run Java, because that's how SAP was implemented. So Java was implemented as a PACE implementation, which is an AIX binary, okay, and which meant we could keep SAP. All of the initial newer languages, the open languages that were first put on the platform, like PHP and Ruby, also took advantage of that as well. And that is critical to that center part of that strategy that I showed you before. Give people open choices on how you want to accomplish things. Continue to do things in the traditional languages that run in ILE and so on, but then allow them to be able to do things with these newer technologies. And that has allowed us to have a hybrid application development strategy where we have some code written in the ILE languages using SQL, etc., and then some things written in this open environment. And that's the strategy that we've been on. In fact, it's one of the key things in many of the sessions that I'm giving about the strategy of IBMI these days related to modernization. Usually people have things written in traditional languages like RPG, Java, COBOL, etc. Okay, but then they add the languages like Python, Node, and so on to extend and do the things that those languages are done. And we have client story after client story after client story where that's being done now. This is how people are modernizing on IBMI, is taking advantage of the fact that we can use these open languages, which are running in the PACE environment, tie them to traditional languages. HATCO is one of them, CRAS is one of them, FibroSID is one of them, CubePack is one of them, where you continue to get significant value from the traditional stuff running in ILE and all the data that's in DB2, but you're also using the value of the stuff that's running in PACE, which is this open environment. This is an architectural picture, a better architectural picture of how PACE actually works. And just with the time that we have left, I'm not going to go into it, but some of you are welcome to take it and go and read stuff that has been put into the user community about how PACE works. But one of the reasons I wanted to show this is that no matter where you are, if you're running the IBMI licensed internal code or you're using PACE from within inside it, we're actually not sitting directly on top of Power hardware anymore and haven't been since the original creation of the Power systems architecture. We're running on top of something that virtualizes the Power hardware for us too, called Power VM, and that allows us to run next to ourselves in partitions. It allows us to run next to the other operating systems that are available on the platform. And yes, I know I didn't change these icons to the newer icons, but I'm saying that historically, this is what they look like when we began to do this. So that's why they're still in their older logo format. In any case, that allows us to do things like cloud, and that's critical. It's important for you all to understand that the architecture of this platform had to be modified so that we could run in a standard cloud environment. There surely were people doing what were called service bureaus, and there were surely people doing what was called and is called software as a service on this platform before it became IBMI. i5OS, even AS400 have some of those service bureau kind of things. But if we were going to get this architecture, this operating systems architecture, so that it could participate in a generic cloud, there were a number of things we had to do to transform it. Fortunately, we had invented the ability to do technology refreshes, which allowed us to put new capabilities into the operating system without forcing a new major release and without forcing retranslation and so on. And so over the course of the 6171 timeframe, we were able to transform this operating system, now named IBMI, into something that could be incorporated into a cloud that was using open technology. So the first things that we did in the 7.1 timeframe were to be able to do things related to virtual media and network installation and suspending and resuming and moving our running operating system. Again, those of you who have only been around for a little while, you may have assumed this was there for a long time. Those of you who've been around for a long time may forget you couldn't do this with the old i5OS, and certainly never could have done it with the old AS400. So in order to move in this environment where cloud is so important, we had to change the architecture. We had to evolve it. And that's critical these days because competitors are out there saying that if you want to do cloud, you've got to move off of IBMI. They are playing on people's remembering this platform as an AS400. Sure, an AS400 couldn't participate in today's cloud, but IBMI can, and we need to make sure that people understand that. I wrote a blog about that earlier this year. This is actually one of the dangers of calling the platform by an older name, because you will find that there are still things you can search and get AS400s, and it shows the limitations that you couldn't possibly do cloud-like things on AS400, but you can on IBMI. And in fact, it's the best way for most of our IBMI clients to deal with the cloud, use IBMI and the cloud together. In fact, we have customer story after customer story of them using cloud technology. And one of the best ones came about during this last year and a half while the pandemic was happening. ID Logistics, a company in France, wanted to get out of the business of managing their own platform. And so they moved IBM I into the IBM cloud. Okay, perfectly capable of doing that ever since the architectural changes that we kicked off in the 7.1 timeframe that now allow IBM I to run in a standard cloud environment. Okay, not an x86 cloud environment, but using standard cloud technologies to be able to do things and manage things in cloud ways. This allows IBM I next generation applications, and you should come and listen to me talk about this sometime, to be prepared to be able to use things in a cloud, and it also allows you to run your IBM I in a cloud if you want to. This is not the only way to run IBM I in a cloud. We have partner after partner. We have companies out there doing clouds of IBM I, but it's also possible to do it in the IBM cloud, which is a key cloud provider for many of our clients. And so you need to understand that the architecture had to evolve to be able to be offered in this way, to be a part of that. And so now as we move into today's requirements for applications, not only did they have to be able to do things like web programming or server-based programming, but we also have to be able to do applications that are married with cloud technology to other applications that are running in a cloud somewhere. And again, we had to evolve the architecture in the ways that I've talked about over the last 10 minutes or so that we could participate in this. We're also evolving the architecture so that we can incorporate open technology that's being widely used to be able to manage systems and manage the deployment of software across enterprises. Ansible is one of those key open technologies, for example. It not only helps you manage multiple platforms of different types using common technology, that's what we've enabled with Ansible and the IBM I modules that we've put out there, okay, but it also allows you to manage the distribution and rolling out of software in a CI/CD or DevOps way in a common set of technologies. Many of our software partners who are creating software lifecycle management are now doing it based on Ansible, because that's the underlying common technology that is used by so many of the industry tooling technologies as the basis. And so we have Ansible for IBM I, use cases for administrators who want to manage the platform, developers who want to be able to develop and deploy things, and then doing cloud things. Another thing that required us to do a significant change in the architecture and evolve the architecture in ways that the original AS400 couldn't was to be able to address the continuous availability challenge. We introduced with the 7.4 release this thing called DB2 Mirror, which is not meant to compete with the high availability products. It's meant to create a continuous availability environment within a data center. What we kept getting asked for was the ability to do something called active-active. DB2 Mirror was created so that you could pair two systems together in a way that one of them could always be up and handling all of your applications. And during most of the time, both of them would be up, and to your applications, it would look like it's one virtual system. You see, in the industry, there was this idea that if you paired two systems together, they could both actively be working against the same data. That was impossible with the architecture that we had, that even PowerHA used with independent ASPs. With independent ASPs, you could have an independent ASP that was being executed against on one system and ready to be taken over by another system, but that second system couldn't be doing anything active to it. We needed to create an environment where you could actively be writing to your database from both systems at the same time. And that required an entirely new architecture for how we updated things at an object level. Most especially for database, because you had to be able to keep your transactions sort of atomic, even if they were being written across both systems. But it's not just the database, it's also the user profiles and so on. Okay, and so we had to create an architecture for that. And we don't have time to go into the details of how that architecture works, but it certainly wasn't built into the original independent ASP architecture. In fact, you don't even need independent ASPs for this to work. Okay, and it certainly wasn't built into the original DB2 or single level store architecture. In fact, for many years, our internal technical people said active-active will never work, because in order to do that, you'd have to have single level store controlled by two different systems. Once we got ourselves past that architecturally, once we said to ourselves, no, if we could find a way to take two single level stores and mirror pieces of them at the same time against one another, we could accomplish this. That allowed us to have an architecture that would allow us to do DB2 mirror. In order for us to create that sort of architecture, by the way, we also had to create an architecture which would allow you as a user to say, what are the rules that I want from my replication? Because while you might initially think that if a person wanted the exact same system to be available on the at any given time on two boxes, you'd want everything replicated. That's not actually the case in practice. In practice, you would want some things to be replicated and some not to be replicated. And in fact, for some user environments, they might want only part of their application space replicated and the other part not. And so we had to create an architecture not only for replicating or keeping things in sync, mirrored at the same time, but also for you to have some level of control over it and not tie the system up in knots. So that was another part of the architecture that had to be created. All right, so over time, what I've tried to get across to you is that yes, there is this core set of the architecture which does owe itself at least as far back as the AS400. And while pieces of that came from the System 36 and the System 38, it is really when the AS400 was created that those 5 architectural elements were created. But I've shown you that over time, even those pieces had to be updated to deal with the changes in the industry, most often because of the kind of software that was going to be used by the solutions that are on the platform, but sometimes because of the hardware technology that was underneath it. Paste didn't exist, 512-byte sectors didn't exist for AS400. All sorts of things didn't exist, and we needed to adapt the architecture to do them. Fortunately, our value proposition has been based on this goal that we had from the beginning, that this operating system could change with technology. It has been our guiding principle. While it would have been easier many times during the transition from one machine type to another, it would have been easier to make a break and say, sorry, you're going to have to re-implement, you're going to have to recompile, you're going to have to rewrite. We had as a cornerstone element, no, our value proposition is finding a way to carry people forward. So we're going to make sure that IBM I, as an architecture, evolves, changes to allow it. That way, no matter what our clients want to be able to do, we can guarantee them that IBM I can do what they need to do. So there we are. That's the end of the charts. Now I think we can go into a Q&A session. If Tom, we have any questions, I'll just leave this chart up while we're talking, and you can tell me if we've got questions.
Questions, and also a point. I'm not sure. I believe you mentioned that you do a blog, and that's always available for people, and that's hosted in the IBM I community website, right? That's
true. That's true. In fact, good point. I will go and post it on Twitter again as a reminder. So you all can follow Steve_Will_IBMI, and you'll find it.
And you can also maybe drop it in the chat. You should be able to send it out to everybody. We have had a great few questions. I'll say, first of all, a lot of comments about great presentation. Did you record this? Will there be handouts? Yes, we did. Those will all come out to you. If you don't get an email from Help Systems, that means you probably blocked this in your spam. And that does happen, you know, as we are a marketing machine also for the IBM I platform. Cool bookcase, toys, and magic cards. Steve, do you mind commenting on what you have behind you?
Yeah, so ever since the pandemic started and I've had to work from home, I've taken what used to just sort of be my man cave and turned it into my office. It's up there as all the sorts of things that make work worth doing, right? I've got the Marvel Universe up there. I've got Harry Potter. I play Dungeons and Dragons and I love miniatures, so I've got that. I've got Tolkien over there. I've got Magic. I have a whole shelf of games behind me because I'm playing games. So this is just the room where I work, and as I look around, I can be reminded of why I work. If you looked over there, you'd see artwork from my grandchildren, for example. So anyway, this is why I work, so I can enjoy these things.
I seem to remember you walking around Harry Potter world at one Common or
did,
IBM Tech U.
Yep.
So serious question. Will there be a TR needed for support of Power 10? Can you share that already, or?
Yes,
What?
every time we do a new Power family, we need to have a technology refresh added to the releases that are going to support it. So just based on when Power 10 is likely to come out, the two most recent releases, 7.4 and 7.3, will need technology refreshes in order to run on top of them. Fortunately, we created TRs. Otherwise, you would have had to have waited for another major release, and we wouldn't want that.
Exactly. Okay. Great question here. Boy, I lost it. There's so many coming in here right now. Where is the one I wanted to read? How will IBM integrate AI with cloud computing?
Great question. Probably take longer to answer than we have time for, but it's important to understand that AI is being offered as basically cloud services all over the cloud these days. And so those two technologies are actually married together in many cases. Most of our clients start out trying to incorporate AI with their existing software by calling out to a cloud service and playing with it that way, maybe even implementing it that way. But then often many of our clients say, okay, I'd like to be able to run that natively on IBM. And with the open technology that we have, many of those modules, for example, that do machine learning and so on, can actually be run in our PACE environment. So there's actually a spectrum of things, sometimes requiring cloud, sometimes not requiring cloud, but it's usually the starting point that people use when they want to do AI.
You know, here's a great question, and I'm going to paraphrase it a little bit. Is there any webinar or seminars or conference coming up on the future where IBMI is going? Where's it going? Where's your money being spent, being invested in? Geared more towards those people who are not necessarily on IBMI.
Okay, so great question. The common conference that we're about to do virtually next week has a couple of sessions where I talk direction. Then the common conference that we're going to have that's in Virginia Beach, there's even more of that. So will there be at the RPG DB2 Summit. So will there be at the IBM Technical University, which I think is going to be a virtual only event. In every one of those cases, I have something that's typically called whatever our theme is for the year. So I think this year it's IBMI Anywhere, IBMI Everywhere. And we use that to describe to clients and potential clients, here's what IBMI brings to the table. In addition to that, Allison Butterell and I are just in the process of revising what used to be known as the YI presentation to show people why IBMI is built the way it's built and the value that they get from it, particularly for people who aren't on IBMI. And that too is going to be part of both of those common events, the one that happens next week and the one that'll happen in Virginia Beach. And if somebody else asks us to do it, we'll do it because it's a key message. It's a good point.
Okay. What are the unique platform advantages for open source on PACE on this platform? And what are the potential compromises from a traditional security aspect? Do you have to compromise your security to run, let's just say open source PACE on IBMI?
You don't have to compromise your security. You have to be aware of what a traditional open source program is going to want, but you don't need to give it any more authority than any other piece of software that's coming out. The advantages of running things on IBM I from the open community are typically related to how close the data is to you. Usually, for any given open language, for example, we write a connector to DB2 that makes it a high performance connector. So rather than going through a traditional file system to do something in a MySQL stack, for example, on a hierarchical file system not written for relational database, you'll be talking directly to our relational database and getting answers much faster. So you actually do gain significant performance benefit often from something that's high transaction based if you're running open packages on pace as opposed to in some other environment.
And I'm almost positive that some of your team members like Jesse will have sessions at the common event. What's the name of the common event coming up next week? Is it
Insight is the one that's next week, and
yes.
then Power Up is the one that's in October in Virginia Beach. So Insight, small I, and then Insight. Go to common.org, you'll find it.
Yeah, common.org. That's probably the easiest way. Thanks, Steve. You know, somebody asked, well, what were you calling it instead of a legacy system? I like to refer to it as a proven system and proven technology. I really think, or if you also hear people talk about IBM I as the system of records too. It is, I mean, it's great at scaling database transactions, I mean, and running applications. Comment from Russell. We own a Power 7 system and we're looking to lease a new Power 9. Any suggestions what we can do with the old hardware without having to pay for an iOS license over there, and instead of just keeping it as paperweight? And then also comment related from, we'll hit Russell's both of them right away. Google searching, he thinks he sees more with AS400 versus IBM I.
Well,
a lot of questions in there.
Yeah, first of all, if you keep searching with AS400, the way Google works, it's going to keep showing you more AS400 stuff.
That's a great point.
But the issue with the AS400 stuff that we find is that often it is very, very out of date. So I realize more people need to use IBM I in their search engines. By the way, it used to be that in order to get IBM I content to show up, you had to actually put IBM I in quotes in Google. Now it's been used frequently enough that if you just put IBM I and then cloud, you'll get something, right? You don't have to put anything in quotes anywhere. So Google is learning, right? Its algorithm is learning that IBM is frequently followed by the single letter I, and when it is, it points you to the new stuff. So I know that that's the case. I'm sorry, I can't give you any advice on what to do with old hardware. First of all, I'm a software guy, and in the second place, your partners would kick me if I tried to tell you what you should do with your old hardware.
Talk to your channel partner, right? That's an interesting thing. I was looking for new garage cabinets, and then all of a sudden, so for some reason, Google started showing me all these different things from Gladiator and New Age, and it's amazing. So that's a great point on that whole AS400 search thing, and I often forget about that. Boy, we have a lot more questions. You have more time, Steve?
I have probably about 5 more minutes, Tom, and then I gotta go.
All right. Can I load Linux on my old i7 in a partition? If it's a power server, right?
If it's a power server, it should be able to load the Linux versions that are on power.
Yes.
It might. Yep.
So it's an i7. So I think he's really meaning it's a Power 7, probably.
If it's a Power 7 based platform, then there is Linux that runs on it. Yep.
Okay, we created an IBM I LPAR on the cloud. What does the IBM licensing be automatically applied? So I think that's one of the concerns people have is when you move IBM I from on-premise to a cloud, what happens with licensing, and what does IBM do with that?
So again, I don't have charts for that right now.
Not the Linda, right?
But you probably will get some benefit from one of the cloud presentations again at one of these sessions that's coming up. But let me just say, in the last 6 months, IBM has created a program which will allow you to essentially take the investment that you made in your on-prem license and transfer that to the cloud. Now that means you'll have to stop using it on-prem, but if that's what you're planning on doing, if you're planning on moving into the cloud, then you can get some benefit from that. Up until about 6 months ago, you would have to purchase in a subscription basis. So on a monthly ongoing basis, you'd have to purchase your new IBM license in the cloud and just transfer your software there. And then many clients felt like, but I've paid for this already. I shouldn't have to do that. And that's fine. If you're willing to not use it on-prem, you can gain benefit from that by having that sort of prepay. But ultimately, if you're on the cloud for a while, you'll have to start paying on a monthly basis for it, because that's how the cloud works, right? Instead of purchasing the activation for it once, you're now paying for it on a monthly basis. And I'm not the business guy, so I may not have said that exactly right. Linda Hirsch has a great document out there on that. And then if you contact me via Twitter, I will try and find you the link.
And absolutely, that's something that's been figured out 10 years ago. IBM's been allowing people to move into the what I'd call managed service providers, which would be, really they're a cloud offering that's existed for well over a decade with IBM and you can transition to those without having to pay for a larger system, for example, to run your business on. So IBM's been great on helping people transition. Somebody also mentioned that, hey, if you have old hardware, their business partner worked with them to pick it up and gave them some credit and a buyback on that through some IBM programs. So you should really talk to your business partner about that. We have a whole question about the value of moving to cloud versus on-premise. What does that mean? There are, I'm going to do a shameful plug. I'm doing a series of webinars, August 17th, 18th, and 19th, talking all about cloud, going to the cloud from a performance perspective, modernizing applications in relationship to cloud, and also some of IBM's cloud offerings. So look for that to come out later. I got some great guests coming for that. Boy, we have a lot of other questions, Steve. I don't know what to tell you. I think you were kind of up on time.
Yeah, well, that's true. So why don't you, send the questions. I'm sure you'll get a log of the questions. Send the questions to me, and if there's something I can quickly answer, that's fine. I totally don't blame any of you who are doing this, but when you're asking questions related to something that's not this presentation, the architecture, I get why you're doing it. But one of the reasons I attend and present at so many different user events and conferences is because I try to answer these in the context of the full picture. So answering a question about cloud after an architecture presentation is a little difficult because I can't give you all of the context necessary to be able to answer the question properly. I really encourage you. You joined this webcast today. That's great. Keep doing it because we're out there. I told Tom, I have presented to more clients in the last year because we're doing this stuff virtually than I have in basically any other year I've been in this job. And it is our strategy to be out there as much as we can. So find us where we are. And it's not just me, right? Jesse Gorzinski, Chris Whitney, Tim Rose, Scott Forsty, Barbara Morris, all of those experts, we're out there so that we can give you the answers in the context that you're thinking of when you're asking the question.
Yeah, the old traditional education to a certain extent is gone. This new web-based thing, there's a ton of education out there. There are so many great webinars that are not marketing events. They are really, training just like we did today for you. So that's a great way to wrap up. It's been a pleasure working with you again, Steve, on this. We'll based on this year's result, we'll see you again next year. We'll change the deck a little bit, talk a little different things. Other than that, I was going to encourage everybody else to do something. Oh, don't forget about the IBM Marketplace survey when we come out with that in September.
Please.
We need you to fill that out. IBM looks at this and all the different business partners that support IBM support you. It is a good artifact for them to make business decisions to better serve you. So thank you. With that, it's been a wonderful webinar. Steve, enjoy the rest of your summer. Hopefully we'll see you maybe in the fall somewhere, but if not, this fall, we'll see you virtually and we'll see you at in the spring of 2022 somewhere.
Sounds great.
Thank you all. Have a wonderful day.